Yes, start.
Okay, so today we will be calibrating a thermocouple. A thermocouple is a device through which we get to know the temperature of the water, what we are trying to do today. So the learning objectives of this experiment is we are trying to learn the theory behind the thermocouple and then the properties and the functions of the thermocouple. So the apparatus used for this experiment is the thermocouple and the RTD indicator. So this is the thermocouple and this is the RTD indicator. This is the thermocouple which we will be using to calibrate, and this is the RTD indicator, which is the standard through which we will get the actual temperature. This is the water heater. We have filled it with water.
Okay.
And this is the indicator box which will show us the thermocouple reading and the RTD indicator reading. So the connections are made initially like this.
Where is RTD connected? Where is thermocouple connected?
So the RTD is connected to the back of this indicator.
Okay.
And this is the J-type thermocouple which is connected over here. We have different kinds of thermocouples. We have the J-type, K-type and the T-type. So, and then this is the knob. So once you connect the J-type thermocouple on here, you change the knob to J, K or T respectively. So the different thermocouples basically used to measure different ranges of temperature. So now we're going to measure from 0 to 100 degrees. So we're using the J-type.
Okay.
These are the different.
Switch on.
So now we're starting off with the experiment. Initially what we need to do is we need to adjust the gain such that they are almost the same, the thermocouple and the RTD indicator.
What does this temperature indicate?
This is the temperature of the water inside. Now what we'll be doing is we'll be taking down values for every 5 degrees change in the temperature. And then we will be taking down the value of the thermocouple reading respectively. Then we will find out the error and then we will find out the correction for the same. Then we will be plotting the graph. We will be plotting the graph. That is
so show me how it is. Okay, it has to rise.
Yeah, it has to rise.
Okay. How do you take the readings? Okay. So explain how your tabulation.
This is the tabulation. So we have different readings. So I have taken random values over here, but usually you take every 5 degrees increase in temperature. So actual temperature which is measured by the RTD indicator. You're writing it as the actual temperature. Subsequently, you're writing the measured temperature, that is the thermocouple indicator. Right now, RTD indicator reads 35 degrees and the thermocouple reads 32 degrees. That means there is an error of 3 degrees.
Error of?
3 degrees.
Minus 3.
Minus 3 degrees. So the correction that needs to be applied is plus 3 for this particular value. Right.
Graph. Show me how you graphically represent the results.
So we have one graph which shows us the measured temperature versus the actual temperature. So we have measured temperature which is in the y-axis it shows measured temperature, on the x-axis shows the actual temperature. This is how the graph goes.
Show me the error curve.
Next is the indicated temperature versus the error percentage.
Okay.
So this is how it goes.
Percentage error. How does it vary?
So it starts off from basically the error percentage varies from 2.5% to almost 19%. So that is a pretty big curve. Also we have indicated temperature versus error, just the error. So the error goes from 1 degree to 7 degree error.
Okay, show me the experiment now. Right, now it has got heated up?
It's still at 45 degrees.
Oh, okay.
Write down the value. After some time you can see the water boiling also.
Okay, as the temperature keeps on rising, you keep on noting down the actual reading and the measured reading, and you have come out with this kind of a
grass.
What do you ultimately conclude by this experiment?
What we concluded from this experiment is we realized why thermocouple is not the standard thing. RTD is used as a standard because the values that we get from the RTDs are more stable and they are more repeatable. Basically, if you repeat the same experiment again, the RTD will keep on showing the same values again and again. But the thermocouple does not do that. That's why it needs to be calibrated very often. That's it. We learned how thermocouples work. Let me tell you the applications of thermocouple.